Hi guys, welcome to Excel and Maths I. Today we'll be looking at how to use the chain rule to differentiate a function. So I've just sort of written a sort of brief description here of what the chain rule is. So we've got dy by dx is equal to derivative of outside times the derivative of inside. In other words, let's look at this one as an example. So in this function here, we have this to the power of 6. So this is the outside part. And what's in the bracket is inside part of the function. So let's go ahead and see how this is done. Once I do an example, this will make it more clearer. So we've got dy by dx is equal to, so we differentiate the outside part, so bring using the power rule. So that will be 2x squared plus 4. So I haven't differentiated the inner part, and I reduce the power by 1, and that goes to 5. Then I multiply by the derivative of the inside part. So I need to differentiate 2x squared plus 4. So if I differentiate that, that will give me, so that will be plus 4 to the 5. Differentiating that will give me plus 4x. And of course, 4 will just be 0. And the final answer would be 24x and 2x squared plus 4 to the power of 5. And that would be my final answer. Okay, let's look at this one. This time we have a tan inverse function, and we've got a 3x squared in the bracket. So in other words, the outer function is tan inverse, and our inner function is 3x squared. So let's go ahead and do that. So that would be dy by dx, and that would be equal to, so the differentiating the outer function, which is a tan inverse, that will give me 1 over 1 plus, that will be 3x squared all squared multiplied by the derivative of the inner function, which is 3x squared, and that would give me following. So I have 1 plus, so if I square that, that will give me 9x to the 4 times, so that will give me 6x if I differentiate this. This would give me my final answer as 6x over 1 plus 9x to the 4. Here's another example. So we have ht is equal to 6t squared plus 9t plus 6 and raised to the power of minus 2. So in order to do this, we apply the same rule, of course, the chain rule. And once again, this is our inner function and this is our outer function. So let's go ahead and do that. So that would be minus 2, that's differentiating the outer part and keeping the inner part as it is, plus 6 times the derivative of the inner part, which is 6t squared plus 9t plus 6. So once we differentiated that, of course, this power reduces to 3, and that would give me minus 2 6t squared plus 9t plus 6 to the power of minus 3. Now times, now we differentiate this, that will give me 12t plus 9, and then my final answer would be, so I can just put my final answer like so. I'll have 12t plus 9 over 6t squared plus 9t plus 6, that would be cubed. That would be my final answer. Okay, here's another one. Now in this one, what we do, we use the chain rule twice, once in the first part and then for the second part as well. So first of all, let me go ahead and simplify that. So that would be t to a half plus e to t squared. Now, to differentiate this, let's go ahead and do that. So I'll differentiate the outer part first portion of this, by using the chain rule. So that will be a half 8t to the minus a half times the derivative of the inner part, which is 8t, plus the derivative of the outer part, this, which will be e to the minus 2t squared, times by the derivative of the inner part of the second portion. So then this would give me, so differentiating this part, that would give me 8, and that would be plus, so I'll have e t squared. Differentiating this part would give me minus 4t. Then this would multiply, half and 8 would multiply, that will give me a 4, so that'll be 4 8t to the minus a half, and this negative will cancel this positive, so that will be negative 4t e to the minus 2t squared. I could either just leave it like that, or I can just put it as so. Just put this in here, and that would be 4t over e 2t squared. So that would be my final answer. Here's another function. Now in this function, what we need to do when we're differentiating this one, we need to use the chain rule 3 times when we're differentiating the outer part, and then when we're differentiating this part and this part. Okay, let's go ahead and do that. So f dash t would give me, so differentiating the outer part, okay, and keeping everything else the same, that would just simply give me as follows. So reducing the power, this is me using the power rule, then multiplied by the derivative of the inner part, and the inner part is as follows, the one in the brackets. That would be sine 2 minus t. Okay. Now this would then give us as follows. So like I said, we just have to be careful here. So that would be, sorry, that would be 2. Now multiplied, now if I differentiate this part, that would give me e to the minus 6t, so that's me differentiating the outer part, multiplied by the derivative of the inner part, that's minus 6t, the inner part, plus, now differentiating the sign, that would give me cos 2 minus t multiplied by the derivative of the inner part, and the inner part is 2 minus t, and then this would give me, and that would be then, so if I differentiate this, that will give me minus 6, so it'll be minus 6e minus 6t, and here when I differentiate this part, this portion, that will give me a minus 1, minus 1 times that would just give me minus cos 2 minus t. So if I put everything together, that would be as follows. So I have my sine 2 minus t squared. That'll be multiplied with. So this would be my final answer. And like I said, you can easily make a mistake, so always double check your answers. So this would be my final answer for this one. Let's look at another one now. So this time what we need to do, of course, we need to simplify this. So we will just simplify this down to, so now that's a cube root and that's a power there. So that would be to the power of, so the power is 2 and the root is 3. So that's my function. So once again, I just do dy by dx. And that would give me, so what I need to do, I differentiate the outer function. So that would be 2 over 3, then keeping this as it is, so 1 minus 8x, and then reducing my power. So the power would reduce to, so that would be 2, I'll just write it in anyway, just to show you. It'd be 3 over 3 times the derivative of 1 minus 8x. So if I go ahead and do that, that's 2 over 3, 1 minus 8x to the power of minus a third. Now if I differentiate this part, remember guys, there's a negative sign, so it'll be a negative 8. And then that would give me minus 16 over 3, 1 minus 8x to the minus a third. If you want to put it in a more simpler form, we can certainly do that. It'll just simply be minus 16 over, then you can put it into a root, which would be 1 minus 8x. Just put a cube root there. That would be my final answer if you want to put it in a simpler form. Of course, there's a 3 there, just missed that there. So that would be my final answer. Okay guys, here's another example now. F of x is equal to cosecant 6x. So how do we go about doing that? Well, once again, we use the chain rule. So what we do, we differentiate the outer function. Outer function is cosecant. So if we differentiate that, that would give me, so f dash x, that would give me minus cot 6x cosecant 6x, and then what I do, I differentiate this. I differentiate this with respect to x. So now this is my inner function. So this was my outer function differentiated. Now I differentiate the inner part, and then that would give me, so if I differentiate that, that would just simply give me 6. So I'll just write 6 cot 6x cosecant 6x. That would be my final answer. Okay guys, now we have another example. So we've got f of x is equal to 12 cos, and we've got bracket 3x plus tan x. Now once again, our outer function is 12 cos, okay, and the inner function is 3x plus tan x. So if we want to differentiate this, we just do f dash x, and that would give me, now the derivative of cos is sine, so that would be minus 12 sine, that's differentiating that bit, keeping this as it is, plus tan x multiplied by the derivative of the inner part, which is 3x plus tan x. If we go ahead and do that, and if we differentiate the inner part, so I'll just write this in first. And if we go ahead and differentiate the inner part, that would differentiate 2. So that would be 3. And that would be plus secant squared x. Then that would give me, so I would need to bring this over here. And that would be minus 12. So then I have 3 plus secant squared x times sine 3x plus tan x, and that would be my final answer. Okay guys, here's another example. Now once again, our outer function is tan and the inner function is 2x squared plus 5x. So if we do dy by dx, so the derivative of tan is secant squared, and then we have this function here which is 2x squared plus 5x, and then we multiply that. Now we differentiate this part here, which is, so that would be 2x squared plus 5x. So I haven't differentiated that. So if I go ahead and differentiate that, that will give me, so I'll just write this here first, and that will give me, so that will give me 2x squared. If I differentiate that, that will give me 4x plus 5. So then I just bring that up here. So that will give me, the final answer would be 4x plus 5 multiplied by secant squared, that will be inside the bracket, 2x squared plus 5x. So that would be my final answer for this one. Okay guys, we have another one here, so let's work through this one. So we have f of x is equal to 10x plus e to the power of 6x squared plus 2x plus 3. Now when we're differentiating this, we differentiate this as normal, but then we need to use the chain rule for the exponential function here. So let's go ahead and do that. So that would be f dash x would equal to, so if I differentiate this part, that will simply just give me 10. Now when differentiating the e to the power of 6x squared plus 2x plus 3, that will simply give me this. Now we need to differentiate this inner part. Okay, that's our inner part. So if I differentiate that, that will simply give me 12x plus 2. So just be careful guys, when you're multiplying this, you're going to multiply it with this, not with this. Okay, so that will be 10 plus, so I have my 12x plus 2, that's multiplied with e to the 6x squared plus 2x plus 3. So that would be my final answer. Okay guys, we've got another one here. So that's f of x is equal to e to the power of 1 minus cos x squared. Now in this one, well, we have to use the chain rule twice, once to differentiate this and then when we're differentiating this part. So let's go ahead and do that. So this is, you just need to be very careful when doing that. So when we differentiate the outer part, we simply get e to the 1 minus cos x squared. Then times, so now we differentiate this top part, okay, this part here with respect to x, we would get, now when you differentiate cos, because you got minus in front, so that would just give me a positive sine x squared, but then I differentiate this part, inner part of this inner function, which will then give me times 2x. So then my final answer would be, so have 2x sine x squared e 1 minus cos x squared. That would be my final answer. So recapping that again, so what we did, okay, we differentiated this part first, okay, which is the outer function, and I got this here. Then I differentiated the top part. Now this also has an inner function, which is x squared. So when I differentiated this, I got sine x squared. And obviously I've got a negative sign, but because there's a negative already there, that made that positive. And then I differentiated the inner part of the inner function, which gave me 2x. And then just multiplying everything together, that gives me my final answer. Okay guys, here we have another one. So we have f of x is equal to ln, and then we bracket 1 minus 6x squared plus 3x cubed plus 2x to the 4. Once again, we're going to be using the fact that if f of x was equal to ln x, and of course f dash x would equal to 1 over x. Okay, that's what we're going to use. So we're going to be using the chain rule, of course. So f dash x. So what we need to do, so we differentiate the outer part, which is ln, and that would give me 1 over 1 minus 6x squared plus 3x cubed plus 2x to the 4. So that's what it would give me. Now I differentiate the inner part. That's multiplied by, so the inner part would be minus 12x plus 9x squared plus 8x cubed. My final answer would be, so that would be minus 12x plus 9x squared plus 8x cubed over 1 minus 6x squared plus 3x cubed plus 2x to the 4. So that would be my final answer. Okay guys, here we have another one. So we have f of x is equal to natural log of tan x minus x to the 4 minus 3x all to the power of 10. So let's go ahead and do this. Now this time we would have to use the chain rule for this function, this part of the function, and this part as well. So let's go ahead and do that. So I'll do this in steps, so I won't be missing any steps out because we can easily miss crucial parts. So if I differentiate this, the outer part of the first part, that will give me 1 over tan x, and that will be multiplied by the derivative of the inner part, which is tan x, subtract. Now I need to differentiate this, so that will be using the power rule, so I'll bring the power down. That will be 10, so that will be x to the 4 minus 3x, so I don't do anything to this at the moment. Then I multiply this by differentiating the inner part. So then I need to differentiate x to the 4 minus 3x. If I go ahead and do that, so if I differentiate the tan x, I'll get secant squared x, and that will be over tan x, and that will be minus, so I have 10. Now if I differentiate this, that will give me 4x cubed minus 3, so I'll bring that here, 4x cubed minus 3, and then multiply it with this here. That would be x, sorry I missed my power of 9 there, So that would be x to the 4 minus 3x to the power of 9. So that would be my final answer. See how I just missed that power of 9? Yeah, you can easily make a mistake, especially differentiating a function such as this, so you always have to be careful. Okay guys, here's another one. So that's ft is equal to t to the 7 square root of 5t squared minus 1. Now this is going to be a tricky one, because what we need to do, first we need to use the product rule, and then in the process we'll be using the chain rule. So now just to remind you of the product rule, so if we have the product rule, so if you've got a function, so let's say we call ut, that is t to the 7, and let's say vt is our this function. So I'm just going to, sorry, I should have simplified that to just put the power in. So it'll be 5t squared minus 1, and that will be to the power of a half. So that will be 5t squared minus 1 to the power of a half. Now if I differentiate this here, so u dash t would give me 7t to the 6, and v dash t would give me, now I would need to differentiate the outer function first, so that would be a half, and that would be 5t squared minus 1. So I'm using the chain rule now to differentiate that. That will give me minus a half. Then I differentiate the inner function, which will be 10t, and that would give me, so 10 times 10t times a half would just give me 5t, so it would be 5t, and that would be 5t squared minus 1 to the minus a half. Now if I go ahead and write my product rule, okay, so that would be f dash t would be u dash t times v t plus v dash t times u t. So all I need to do now is substitute all these values in there. So u dash, so I'll just start on this side here. So I'll just start from here. So u dash t I've got here as 7t to the 6 times vt, and my vt is this here, so that would be 5t squared minus 1 to the power of half. Then I have plus my v dash t, so that is v dash t is this here, so that would be 5t squared minus 1 to the power of minus a half, and that would be times by ut, so that would be by t to the 7. So what I'm going to do, I'm just going to bring all this up here, so my final answer will be as follows. That would be to the power of half, so 5t times 7t, t to the 7, sorry, that would give me plus, that would be 5t to the 8, 5t squared minus 1 to the minus a half. So that would be my final answer. Okay guys, now this is the last one. We've got f of x is equal to 2 to the power of 1 minus 6x. Now in order to do this one, what I'm going to do, I'm just going to draw your attention to this result. So if we've got d by dx of number a, which is raised to the power of u. Now if we differentiated that, we would get a to the u times log, that's natural log of 2 times u dash. So that would be our result. So let's go ahead and do this. So if I do f dash x, I would get, so differentiating the outer part, that would give me 1 minus 6x times the natural log of 2, then multiplied by the derivative of the inner part, which is 1 minus 6x, so then that would give me 1 minus 6x times natural log of 2. Now differentiating this part would give me minus 6. So my final answer would be minus 6 natural log of 2 times 2 to the power of 1 minus 6x. And that would be my final answer. Okay guys, if you like the videos and like the work examples, please subscribe to the channel, hit the bell icon to get the latest updates, and give a thumbs up. Thank you for watching.